Okay, so let's do some example problems of our grade resistance. Again, remember our formula, it's up on the top of the page there, is F is W sine of theta. W is the weight, theta is the angle of inclination, and F is our grade resistance that we're talking about. So in number 6 here, where they're asking find the grade resistance, so we need to know what F is, right, to the nearest 10 pounds of a 2,000 pound car. So they just told us how much the car weighs, right, traveling on a 15-degree uphill grade. So they just told us what theta is. So all we need to do is go to our handy-dandy formula over there and plug things in. So F, I don't know. The weight, I was told, is 2,000. And we're going to take the sine of the angle of inclination, which is 15 degrees. Now again, this is an exact answer. All right, that's what the exact answer exactly is. But if we go to our calculator, we can get an estimate, and then we can do what they're asking for, which is to round to the nearest 10 pounds. All right, so bringing my calculator over here, hopefully we can see it okay. Turn on. All right, let me clear some previous work out. And basically what we have is we have 2,000, and we're taking the sine of 15, and what that's giving me is 517.638 yada 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 pounds. Okay, but they want us to basically round to the nearest 10 pounds. So there's your 10. So it looks like our estimate is 520 pounds, right? So we're going to look at the 10 spot. The 7 right below it says we need, or right to its side says we're rounding up. So my estimated answer will be 520 pounds, right, heading down the hill, right? So if the car weighs 2,000 pounds, 520 pounds will be heading down the hill or sitting in that little block that's keeping the car from rolling down the hill, right? So that would be the forces all involved there. So pretty easy application since we did all the groundwork and found a nice little fancy formula for ourselves. So the next one, the grade resistance of a car on a 5-degree uphill grade is 200 pounds, right? So lots of words there. Let's break it down. First of all, they told us what theta is, right? So we're on an uphill grade of 5 degrees. And the grade resistance, right, is 200 pounds. So they basically told me that that's 200. So what is the weight of the car? Well, there's my unknown, right? And so again, plugging things, here's our formula. Plugging things in, my force, my grade resistance is 200. The weight is not known. And the angle of inclination, right, is 5 degrees. And so again, to solve this for W, I would take both sides and divide it by the sine of 5 degrees. And what we end up with, after everything cancels out, we end up with W, right, equals 200, the sine of 5 degrees. So again, there is your exact value, right? That's what it's exactly equal to in terms of this. I'm not asking, it doesn't seem like they're asking to round off to any nearest thing like that. So maybe they're wanting an exact answer, but class rule is 4 degrees. So just to practice our calculators, right, what I would do, again, in my calculator, I type it this way, and our estimated answer, let me bring our calculator back over here, right, is we've got, let me orientate that right, still trying to get used to this. So we got 200 divided by the sine of 5, and it looks like we get 2,294, and that would be 74.26. And again, this would be in pounds. So again, back to my picture, we're told that the force going down the hill is 200. The force due to gravity, that's the weight, is 2,294 pounds, right? Almost 3/4 of a pound more. So that would be the estimated answer as opposed to our exact answer. Again, know how to do both. Set up your equations, show me how you're solving for things, right? Come up with an exact answer, and then turn to your calculator. That's probably the best practice. One more, reading the next one, it says that a 2,500 pound car has a grade resistance of 125 pounds. What is the uphill angle? So it looks like they gave us W. It looks like they gave us the grade resistance. And so what's not known is the angle. So again, going to our handy dandy formula, right? We're going to plug in what I know. This is 125. This is 2500. And then, of course, since I don't know the angle, I really can't find the sine of that. So solving for that, I'll first divide everybody by 2500, right? And so we end up with the sine of theta equals 125 over 2500. If we reduce that, let me just go to my calculator and get that done. So 125 divided by 2500. If I reduce that, that's 1/20th. So the sine of theta is 1 over 20. All right, and so what about our theta? Well, to find it, right, we're going to have to invoke our inverse sine. So theta is the inverse sine of 1 divided by 20. So that's how we're going to enter in our calculator. So again, there's your exact answer. To get an estimate, we will now turn to the calculator, and we're looking at the inverse sine of 1 divided by 20. And it looks like it's 2.86598. And we'll have to be careful here because that means that's going to turn to a 0, which means that's also going to go up. So we got 2.8660, right, degrees. And so there would be our rounding off in terms of the, oops, I said the nearest tenth. I better read my own directions. So there's our tenth. So it looks like theta is estimated to be 2.87 degrees, right, following my directions. So I was going to all the way to 4 decimals. I only asked for tenths. So 2.87 degrees. So there's your formula. Figure out what's given, plug it in, and then solve. You should have an exact value along with an estimated value. And again, just what you round off to depends on what they tell you to do. Alrighty, so that wraps up 2.4. Lots of right triangle stuff, solving it now that we have that right triangle definition. If you have questions, please ask. Practice your knowledge on Canvas. Practice showing your work, and I'll give you feedback. Get ready for the quiz, and we can move forward. And we'll move into 2.5, where our life gets a little tougher, even though we're still solving right triangles. So get ready. Here we go. See you guys in the next videos.